Today our practical is Introduction to Shape Memory Alloys. In here I will explain what is a shape memory alloy, what's the theory behind them, that means the phenomena behind this shape memory alloy, and I will practically show you how the shape memory alloy works due to the temperature changes. So what is a shape memory alloy? It's a metallic material. It's a stimuli responsive material, and the specialty of this material is it can remember their original shape. And when those materials change their shape because of temperature changes, we called it as thermal induced shape memory effect. So this is the phenomena behind the shape memory alloy. There are mainly two types in shape memory alloy effect. One is one-way shape memory effect, another one is two-way shape memory effect. In one-way shape memory effect, the effect only appears in heating cycle only, and in two-way shape memory effect, the effect both appears in heating and cooling. And how it works? The theory behind this phenomena is it's the phase transformation, and the stable phases in this phase transformation is phases are austenite and martensite. Austenite is normally appear in high temperature ranges, and martensite appear in lower temperature ranges, and it's a soft, easily deformable material phase. And martensite can seen as two forms here, thin martensite and built-in martensite. Then I will explain how the phase changes happens due to the temperature changes. In room temperature, martensite is the stable phase in material. That means there are 100% martensite in room temperature. When it increases the temperature gradually, it starts to form austenite in martensite. When it increases the temperature further, the portion of austenite in martensite will increase, and in this spot it will finish the formation of austenite when it comes to the 100% of austenite. And this cycle is for one-way shape memory effect, and when it comes to the two-way shape memory effect, this cycle added to the material, and those two cycles appear in material. In cooling cycle, in hot stage there is 100% austenite. When it gradually cool the material, it start to form the martensite in austenite. This is the point which is start to form martensite in austenite, and when it gradually increase the cooling, that means decrease the temperature, the portion of martensite in austenite will increase. You can see in here it's gradually increase the percentage of fraction of martensite in austenite. Then we come to this point. Martensite formation will finish. This is the martensite finishing temperature, and there is fully martensite phase in material heat. Those two phases are both cycles are appearing two-way shape memory effect. This cycle is only for one-way shape memory effect. And then I will explain what are the changes of macrostructures and microstructures of those two phases. As I have mentioned before, martensite you can see in two forms, twinned martensite and V-twinned martensite. There are two different microstructures, and the macrostructural views are also differ from each other. In V-twinned martensite, there is macrostructural change appear here. You can see the deformation here on those two faces. You cannot see shape changes. That means there is no visible changes, deformations. That's why there is no difference between those two macrostructures in austenite and twinned martensite. And microstructures are different from each others, and there is three different microstructures in those three forms. In the beginning of this practical, I have mentioned that there are two stimulus which is caused to add significant amount of properties to shape memory element. Those two stimulus cause to form two important phenomena to shape memory element. So those phenomena are shape memory effect and pseudo elasticity. So shape memory effect, I have already discussed with you. I will briefly explain this diagram again. So shape memory effect is a recovery of strain that strain has given in lower temperature, and this recovery happen as a result of heat. So that is the shape memory effect. Then in room temperature you can see twinned martensite. It's the self-accommodated phase because in room temperature twinned martensite is the stable phase. So when it loads, it turns into V-twinned martensite, and you already know when twinned martensite forms into D-twinned martensite, there is a macroscopic structure change happens. So it has deformed when it came to V-twinned martensite. So this deformation happens because of the load. That energy stored as strain energy, and you can recover the strain using heating. When it heats, it comes to austenite, and the material comes to its original shape. Then when it cools, after passing those four temperatures, it came to room temperature and turned into twinned martensite. So that is the shape memory effect. And next one is pseudo elasticity. So pseudo elasticity is happening when it applies mechanical load. When it applies mechanical load, it forms. It have ability to form V-twinned martensite, but in elevated temperature zone. That phenomena is called pseudo elasticity. So when in room temperature you can see twinned martensite. When it heats up, it turns into austenite. Then when it loads, you can form V-twinned martensite in elevated temperature. So when it unloads, you can also get austenite again. So that is the pseudo elasticity. Now I will move into the practical. I will demonstrate the shape memory effect. Next, what we are going to do is, we have a nitinol coil. So we heat the coil using water bath, and while we are heating the coil, we are observing the temperature and shape of the coil. So what you are going to do is, you have to read the austenite starting temperature and austenite finishing temperature. So how you gonna do? How you gonna find find out the austenite starting temperature and finishing temperature. When it start to form austenite in martensite, in that moment material start to get to its original shape. So in material it start to change its shape. So when the point which is start to change the its shape, that's the point which is the austenite starting temperature. So when it further heats, material change its shape, and when it comes to austenite finishing temperature, it stops the changing of material's shape, because it already came into its original shape. When it further heats, there is no shape changes. So how you gonna point out that austenite finishing temperature is when it come to that point, after that point there is no shape changes. So I will move into the practical. You should find out the austenite starting temperature and austenite finishing temperature. Seems like phase transformation has already finished. So I will stop the practical.